And for those who are wondering, yes, Mr. Sebastian is son of Mr. Alfred Heinzel.
Yes.
Mr. Heinzel will speak today about smart industry. Sebastian, floor is yours.
Thank you. Thank you very much to all of you for coming to this 10-year anniversary, and thank you for your speech right before that. We are very happy to enter in exactly that kind of dialogue. What do all of us have to do together, and what can we do together to grow this company even further and to have a much bigger 20-year anniversary in 10 years from now. We will all have the opportunity to celebrate together at the dinner. As Lauri just said, and I'm sure he has already a lot of ideas of what he would do with a 50 million investment portfolio. I will now speak, focus on the smart industry, the factory of the future, Industry 4.0. Some of the topics, some of the questions that were raised here today were with the direction. Which direction is industry going? Which direction could Estonia be going? Which concrete direction is Estonian Cell going? And I hope I can provide some impulses and some ideas and some vision around that. Why can I actually don't see it, you see it here. Why can I speak about Industry 4.0? A little word about myself. I've been part of the management of Heinzel Group for the last 3 years, but in the 5 or 6 years before that, I was building an internet startup company. Tripwolf, a provider of mobile travel guides and travel apps, a purely digital business, a purely digital business model. Since then, and I built up that company and sold it with my partners back in 2013 to a German publisher. And since then, I'm in the Heinzel Group, purely physical assets, purely physical products. So quite a distinction from what I was doing before. What Industry 4.0, or how it's sometimes called the industrial internet is actually where those 2 points, the physical and the digital, start to converge to create new value. If I talk about Industry 4.0, of course the obvious first question is what was 1, 2, and 3? If we talk about industrial revolutions. The first industrial revolution took place in the late 18th century. We're talking about mechanization, the usage of steam power, the first mechanized heirloom. The second industrial revolution took place in the early 20th century. Here we talk about electricity usage for mass production. We talk about assembly lines. The car industry with Ford comes to mind. The third industrial revolution was then in the 1970s when computers and automation and electronic controllers for machinery were introduced and machines got maybe a little bit smarter for the first time. And now the fourth industrial revolution, we're talking about cyber-physical systems, or if you want to put it in simple terms, this is smart machines talking to each other. Now the term Industrie 4.0, Industry 4.0 was actually coined by Germany, by German industry in tandem with German politicians who want to who put a lot of effort and money and brain power behind this Industry 4.0. Why? Because Germany is very nervous about their own car industry. They've seen exactly, and Nokia has been mentioned twice before here today, they've seen what happened to Nokia, how a leading European producer of mobile phones suddenly was swept away by software platforms, usually coming from America, that figured out that the value is nowadays in the software and not so much in the hardware. So Germany is nervous that in the long run, their cars will be just their car production will have the same fate, the same role in the value chain as a producer of electronic parts of let's say Asian origin in the mobile industry. So to say, the car industry is only the dumb part, while the smart part, the value creation actually takes place by American companies. Usually it's Google, it's Apple, it's Facebook, it's Amazon. That's what keeps Angela Merkel up at night. Maybe that's why she looks a bit worried here on this picture. And the most present danger for the German car industry is actually Tesla. Tesla, the electronic cars, you know them, or you have heard about them. Maybe some of you have sat in one of them. This is really a product of the future, not a dumb car, so to say, anymore, but a car that gets better and better and better. It's like with your smartphone. You might enter your Tesla in the morning. There's a new software update available. You download the update, and suddenly you have a car that has an autopilot function. Other examples of how Tesla makes its own product smarter. They figured out that with certain road conditions, with certain speeds, there was a higher likelihood of a tire puncture, a flat tire. They were able to gather the data of the cars and then simply send a software update to all Tesla cars that would slightly adapt the suspension when those road conditions and speed conditions were present. And the consequence is less punctured tires, less flat tires. So this is a product that is not finished when it's shipped. It keeps getting smarter. And this is exactly what Industry 4.0 is about. Now, of course, here at the Estonian cell, we're talking about pulp. Pulp in itself will not become a much smarter product, but there's a lot of things that can be improved in the production process of it. And also here, Tesla is showing the way they not only have smart products, but also smart processes. Here's a picture of a Tesla assembly line with a high degree of IT and technology, and actually quite some capital intensity. Now, since a few years, Germany is putting a lot of effort in developing Industry 4.0 initiatives. All the car makers are there, Bosch, Siemens, lots of other European companies are joining in. So what are the technological drivers behind Industry 4.0? It's actually a conflation of many technological developments that now come to fruit and lead together, and I'm going to give a few examples. There's robots, there's new simulation capabilities, there's the industrial internet, or what it's sometimes called the Internet of Things, appliances and machines that are connected to the internet and capable of speaking to each other. There's the cloud that makes processing power available in large numbers. There's things like 3D printing and augmented reality. One of them, and probably the starting base for Industry 4.0, is this famous Internet of Things. In essence, this means you have a traditional machine, a traditional appliance, but you have smart sensors integrated so that that piece of equipment actually knows its own state. It measures its own temperature and pressure and input and output, and becomes to a certain extent aware. This opens completely new possibilities. Take the example that a machine, a piece of equipment, notices that it is about to have a problem, that there is a malfunction coming up. In the Internet of Things, it can automatically tell the next machine down the line that might be damaged to shut down. And this machine can automatically tell the maintenance team to come to it and to take care of this problem. Of course, this introduces completely new methods or opportunities of production improvement, of predictive maintenance instead of reactive maintenance. This is a big topic in a pulp mill. You want to keep a pulp mill running 24 hours a day, 7 days a week is possible, and to react to a problem that surprises you, that's exactly what you don't want to do. You want to catch problems in advance and fix them, and this is exactly what smart sensors and the Internet of Things can do, which then leads to less downtime and therefore more output. Augmented reality is another part of this. Today we have new human-machine interfaces, as they're called, new ways to display data that can help in an industrial setting. This man here wears a smart helmet. He has on his screen superimposed on reality data that is coming from the machines, maybe instructions of what should be the next step in his maintenance task list, directions, how to find his way through the mill. All of this is becoming possible. DHL, the German delivery company, is already experimenting with this. There is an example here. Maybe you remember the big hype about the Google glasses 1 or 2 years ago. It didn't work out as a consumer product. People thought it looks strange, but actually in an industrial setting, this makes a lot of sense. Here, a DHL delivery worker can find his way easily and much more efficient through the warehouse, pick the right product at the right time. So augmented reality applications are coming to the factories as we know them today. The next thing is integrated supply chains. If you imagine that in your factory, each piece of equipment, each machine produces a stream of data and talks with the other machines, of course that's not limited to your own company. You can start talking automatically to the next company. We're having some instances of this in one of our pulp factories in Pöls, where purchasing of smaller items gets automated through an electronic platform. If you think of the context of Estonian cell here, this could be for the timber supply chain. This could be sensors on the trees that send data about the maturity of the tree or of the quality of the tree. The same works not only with suppliers but also down the line with distribution and customers, thereby making it possible to reduce stock and making all the supply chain more efficient. Another element of Industry 4.0 is advanced robotics. We saw the picture of the Tesla assembly line before. This is a picture of Adidas, the so-called speed factory that was announced and shown to the media late last year. This is the first time that Adidas, the sport shoemaker, is putting a factory in Germany and not in Asia. And this works because there is such a high degree of automation that these robots can make individual customized shoes that people designed for themselves online. Again, big part of the industrial internet or Industry 4.0. Another big element of Industry 4.0 is big data. This is a word that probably all of you keep hearing since a few years in all industry discussions. What does it actually mean? If you think of your own company as composed of different pieces of equipment and machine that constantly send data, produce streams of data, then you also need to do something with that data. You have the opportunity to do something with that data. You can make big correlations, you can crunch the numbers, and today with the cloud it is actually possible to do these computations. This would not have been possible on a compute in the past, but nowadays you upload the data into the cloud, you use the power of thousands of processes to crunch numbers of a size that were not possible before, and you can build models about the interaction of your logistics and your production data, the influence of the weather and the outside temperature on our production processes in the mill. You can bring all of this together to draw conclusions that you have never been able to draw before. Again, in one of our mills in Laakirchen, we're already employing such a big data solution to find new correlations to improve production efficiency. And the next step that this makes possible is that you can actually make big and powerful simulations. Because if you think of it, at some point, if every piece of equipment in your factory is producing data, what you've actually created is a digital copy of your factory. You suddenly have your, next to the physical factory, a second virtual factory, and then you can run simulations in this virtual factory. Simulations that would be much more costly, much more time consuming if you would do it for real, but you can test your new theories, your new production methods in the virtual plant before you do it in the physical plant. And this becomes even more interesting in a capital intensive industry when you have to build a completely new plant, or for example, if we would put a second fiber line next to the existing one here, and we could simulate the whole project virtually before we do it, that of course would bring down the risk and the cost associated substantially. Now, I would argue that all of this is happening. All of this is going on in different instances. In some cases, it's just the sensors or the first big data applications, but the trends of where these developments are going are becoming clearer and clearer. I would also argue that Estonia is in quite a good position to take advantage of these trends. We've heard the Estonian government's attitude towards e-government leading the way in this field. That of course means a certain digital infrastructure is already in place and can be built upon. Also the fact that two of the biggest trading partners of Estonia are Germany and Finland, both of which have declared that the industrial internet is a big topic of the future for them. It means you're in a well-positioned place, and the skill set of the, and we also heard from Mr. Dominik also the skill set of the people in the country is there. Of course, with Industry 4.0, there's also risks and challenges. Two of which I'm going to point out now. One of them is, of course, data security. Now our physical plants are secured. You have to pass a gate and the identity check if you want to come in here. Once all our companies are connected and interrelated, of course we need the equivalent of our physical security also in the world of data, to be safe against industrial espionage, against industrial sabotage. And data security is a big underlying topic that needs to be solved, and again where Germany is putting a lot of effort. And I guess also in Estonia there would be a particular sensitivity to it, because the big neighbor Russia has sometimes been accused of state-sponsored hacking. The other big topic is, of course, the employment effects. Some people think that the Industry 4.0 will actually lead to a destruction of jobs. Here is a picture of one single man working in tandem with a row of robots. Now, of course, you could cynically say that this is not a problem for Estonia anyway, with a shrinking population, but that, of course, cannot be the solution. I personally believe that with the industrial internet, there will be new types of jobs, new professions that we now can only guess at. And I've personally seen this effect. When I was working at my company Tripwolf in 2008, we hired these kind of people. We hired mobile app developers and social media interns and digital marketing specialists and SEO specialists, that stands for search engine optimization specialists. All of those jobs had not existed just a few years earlier, and then sometimes we had to come up with the job profiles ourselves. Nowadays, that's completely common professions. If you Google any one of them, you will find a lot of job openings online. And I would say that the same will happen with the industrial internet, with Internet 4.0. I think that every bigger company will have in the future a chief data officer, somebody who's in charge of collecting all the data, making sure that it's not siloed in one department, that one department knows one thing and another department knows another thing. And because data is becoming ever more important. And I also think there will be quite a few other jobs of the future, from application engineer to user interface designer, systems integrator, data scientists. These will be the names of the jobs of the future, many of them on the intersection of mechanical engineering and software engineering. And also from my experience, I can say that probably the most valuable jobs, the most valuable people will be exactly those translators that can translate between the two worlds, that understand business processes and business logic, and at the same time can speak the language of IT and of programmers. Probably even research and development and IT departments will begin to merge in the future. Now, what's the role of the Estonian government or European governments in this? I think the biggest task here is actually in the education sector, to prepare people for exactly those kind of jobs. My kids are now 2 years old and 4 years old. I have no idea what their world of work will look like, but I know we need an education system that prepares them for the eventualities of the future. What are we doing at the Estonian Cell? We are very proud that we are already one of the most productive companies in the country, and we're working hard to become even more so. In the Industry 4.0 will help us with that. Of course, this is always associated with investments, and we will invest if the conditions in the country are right. And the other thing that we know is that with the core values of the Heinzel Group, responsibility, excellence, respect, and above all, entrepreneurship, will serve us very well also in the factory of the future. Thank you very much.
Thank you, Sebastian, for the exciting presentation. Would you be ready to take a question?
Sure.
I want to ask you one question. If you take this factory behind you, or behind me, in front of you, one first thing that comes up to your mind that you can do in order to digitalize this factory?
We actually have an automation team here in the factory that has programmed the mill information system and is constantly working on those things, coming up with new ideas. But the first thing that always comes to my mind is supply chain and integrating the deeper with logistics players, both coming in and going out. Maybe that's because I'm very much sales oriented, and I'm always very interested in the final product and what happens next with it, but that's exactly where I would look first.
Kas saalis on veel küsimusi? Ei ole. Then I would like to use opportunity also to ask one question from you, sure. Not to speak only about this exciting future, but as we heard, as Mr. Meyer said, your family has been recently invested quite a lot. It was some 400 million euros into Pöls. There was a plan to invest another 100 million into Laakirchen paper mill in Austria. People are often asking from me, why should anybody invest into this shrinking pulp and paper sector? Oh. What is your comment about it?
Well, it's not one. Can you hear me like this? It's not one pulp and paper sector. It's many pulp and paper sectors. Of course, anything that's printing and writing, that's publication paper, that's paper used for reading is going down because people read more on their mobile phones and on their iPads and so on. But packaging, huge part of the paper industry is growing, and it's growing nicely, and is growing together with GDP. Our last investments were all in the packaging direction. The Starcraft mill, Starcraft machine in Pearls for paper bags, white paper bags, or now the recent conversion in the just announced conversion in Laakirchen, where we go into container board boxes. These are sectors that are growing, and I think actually the Laakirchen example shows pretty nicely what's going on. Today we're producing magazine for catalogs there. In a year from now we will be producing the brown paper for boxes there. People read less newspapers, but they order more from Amazon. There's much more cardboard boxes needed, and that's a trend that's only growing. I've mentioned printing and writing, I've mentioned packaging, but the third big one is of course hygiene. Some of the pulp that gets produced here in Estonian cell goes towards hygiene production, and that is a sector that is growing worldwide, especially in the emerging economies. If you think there's whole countries that have reached a certain income level where populations start using disposable diapers for the first time. That's a huge driver for pulp demand. So yes, we should be worried about the future of printing and writing focused paper production. If you're not one of the best and most competitive producers, you should probably get out of the way. But I've no concern about the future of packaging and the future of tissue. And also in printing and writing, if you are the most competitive player in the field, these papers will not disappear. They will stay. They will go to a lower level. But it's a famous sentence that no media has been replaced by new media. TV has not replaced radio, and cable TV has not replaced public broadcast, and radio has not replaced the book. So yes, we split our time across more media, but paper will be part of the mix always.
Thank you, Mr. Sebastian Heinzel. As Heinzel will stay with us full day and also evening, you can have the discussions also later on with Sebastian. Now we have to continue with our program.